Okay, so this is simple aromatic substitution problem. We start off with benzene and we need to add an ethyl and a bromine to the benzene. So the first step is to figure out which substituent group we want to add first. We have to add the ethyl group first because it's the bulkier group and it's going to be the director to the bromine atom. Right, so to add the ethyl group, we need to do a Friedel alkylation. So for Friedel alkylation, we know we're going to need to do an ethyl attached to a chlorine, which is going to be the leaving group, and then we also need aluminum chloride too. And that's going to basically install, so this is step 1, right? Drawn out. And that's what we're going to get. Step 2, we need to install the bromine next, right? But ethyl, that is a ortho para director, right? So it means that bromine can either go in the ortho position, which is right here, or it can go in the para position, which is right there. We need it to go in the ortho position, right? That means it can't go into the para position. But because ethyl is closer to the ortho position than is the para position, steric hindrance will push the bromine to the para position. So we have to install a blocking group. And we're going to use fuming sulfuric acid to be the blocking group, right? So step 2 is fuming sulfuric acid, right? So that's H2SO4. And that's going to give us this very bad benzene, I should say, the ethyl group. And it's going to install H3, so SO3H in the para position, right? This is para to the ethyl, right? So now the bromine, right, has to install in the ortho position, right? We're forcing it into the ortho position. So, oops, wrong thing. Yep. So we now have to get bromine in there for bromination, right? Br2. You can do Al Br3, or you can go Fe Br3. Both will work, and that will give us SO3H, the ethyl, and bromine right there, right? So now we have the ethyl, we have the bromine, and we have to get rid of the sulfur, right? We have to get rid of the blocking group. So the next step will be step 4, and we're going to reduce the sulfur. So we're going to do H3O+, and we're going to use heat. The triangle just stands for heat, and that will get rid of the blocking group. So we are just left with bromine and the ethyl, and we have our final product. Alright, so just to go over the reaction again, the first step is to install the ethyl group, which is going to be our director in this reaction. So CH3, CH2, with a chlorine leaving group attached to that ethyl, and then it has to be with aluminum chloride. And then the next group is to install our blocking group. So we need fuming, which is very important. Fuming, sulfuric. Oops, I did that wrong. Fuming sulfuric acid. Then we have to install the bromine, because now we'll be forced to go into that ortho position. Fe. Oops. 3. And lastly, we get rid of our blocking group with H3O plus and heat, which is also very important. You need to include the fuming and the heat.